Hey guys, today we're going to talk about exterior angles in different polygons. So an exterior angle in a polygon, let's say we'll work with a pentagon. So all these angles on the inside are interior angles. An exterior angle comes up if you were to take one of the sides and you were to extend it. So this right here would be an exterior angle. Call it X. So this is an exterior angle, and at every interior angle, you can always extend the side and make a new exterior angle. So for every interior angle, there's an exterior angle that goes with it. So every interior angle, there's like an exterior angle that matches up with it. And if we just focus on two of them, the relationship between the interior angle and the exterior angle is that they're supplementary. So x plus y equals 180. So every interior angle that goes along with its exterior angle, that pair, those two angles add up to 180. And that's true for all polygons, not just a pentagon, for anything. Like if you had a triangle and you were to extend one side, the interior angle and the exterior angle are going to still be supplementary. So that's what an exterior angle is. And one of the main relationships is that it's supplementary to its corresponding interior angle, to the interior angle that it goes along with. That's one really special property. Another really special property, I'm going to rechange these now, we'll stick with a pentagon, is let's say we'll number them 1, 2, 3, 4, and 5. This property is true in all polygons as well, so not just pentagons. If you add up the exterior angles, so if you add up angle 1 plus 2 plus 3 plus 4 plus 5, if you add up all their measures, angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5, they're equal to 360 in all polygons. So it doesn't matter if you're in a pentagon, a quadrilateral, a triangle, an octagon, the exterior angles always add up to the same thing, and that's 360 degrees. So they can be different measurements, but their sum of those 5 angles in this case would have to be 360. If you were working with a quadrilateral and you were to extend all the sides like so, all of the exterior angles, right here, 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 and here, those 4 angles are still going to add up to be 360. In the quadrilateral, in a pentagon, whenever you add up all of your exteriors, they equal 360. So let's look at a nice little example of how we can use this, and very similar to how you use the interior angles. So our first one, we have, let's see, this figure here looks like this, kind of like this, and we are given some exterior angles. We're given that this angle is 44, this angle is 95, this angle is 61 degrees, this angle is 50 degrees, and this is just angle 1. And we want to find the measure of angle 1 here. So if we look, we'll notice we're given all exterior angles, and the relationship that we know is in any polygon, the exterior angles are going to add up to 360. So we can simply say 50 plus 61 plus 95 plus 44 plus angle 1, I'll write the measure of angle 1, equals 360, because that's the special relationship with exterior angles. So when you go ahead and combine your like terms over here and you do your 50 plus 61 plus 95 plus 44, you should end up with 250. So the measure of angle 1 plus all of these combined together equals 250, and that equals 360. So that means when you subtract your 250, the measure of angle 1 should equal 110 degrees. So that's going to be our measure for angle 1 here. So we can use this new property in polygons. All the exterior angles add up to be 360. We can use that to find missing measurements. So this would be 110 degrees. Now, one thing is you have to be really careful with what angles you have. So let's look at our second example here. In this example, we have a figure that looks like this. And then we go through like this. And we are given that this is angle 1. This angle is 85 degrees. This angle is 59 degrees. This angle is 57 degrees. And this angle is 61 degrees. So let's see. Again, we have a pentagon. 1, 2, 3, 4, 5 sides, 5 interior angles. And our goal is going to be to find the measure of angle 1. Now, if we look at this, we are given angle 1. We don't know its measure, but we're interested in it. We're given 85 degrees, 59, 57. Those are all exterior angles. And we're given an interior angle here. So right now, if we want to try to find angle 1, we could say 59 plus 57 plus 85 plus the measure of angle 1 equals 360, but we also have to account for this angle here, because that's one of the exterior angles. So we need to figure out what this angle equals. Well, we know the interior angle is 61. We'll call this angle x. We know the interior is 61. We don't know the exterior, but we know the relationship between those two is that they are supplementary. They should add up to be 180. So when you solve for x, well, you're going to get x is 119. So this angle is 119. So in this equation, we can add that 119 up there. So then we can go ahead and say 59 plus 57 plus your 85 plus 119 equals a total of 320, plus the measure of angle 1 equals 360. So therefore, the measure of angle 1, when you subtract your 320, should be 40 degrees, meaning that this angle has to be 40 degrees, and then all these exterior angles will add up to be 360. We're going to try 2 more of these, using just things that we've done in the past, different concepts, combining them together here. So our next one, we want to find the value of x here, and we want to find the measures of each angle, each exterior angle. And here's what we have. And then we go kind of this way. So we are given this angle is 2x, this angle is 85 degrees, this angle is 95 degrees, this angle is x, and we're trying to find the value of x and the measure of these 2 angles. So notice we have a quadrilateral, but this new rule with exterior angles adding up to 360, that's true for any polygon regardless of how many sides. So look at our exterior angles. We have 1, 2, 4 of them. We have the 4 exterior angles. So 95 plus 85 plus 2x plus x should equal 360. And when we add things together, we get 180 when you combine these together, plus 3x equals 360. So 3x, subtract 180 from both sides, equals 180. Oops, minus 180 from both sides. And then if you divide by 3, x should equal 60. So there's your value of x. And then when you substitute back in, well, 2 times x would make this 120 degrees. This is just x, so it would be 60 degrees. If you wanted to find the interior angles as well, if you wanted to find these insides, well, you could just simply say, like 95 is supplementary to this angle, so you would do 95 plus measure of angle 1 equals 180. And then you're going to find out that this angle is 85 degrees. And you'll find out up here, you're 95 degrees. This angle here, well, since this one's 60 down here, and these are supplementary, you'll find out that's 120, and then up here you'll find out this one is 60. Now this is just a coincidence that we have the same numbers on the inside as we do on the outside, just kind of scattered around a little bit. It's just not always going to work out that way. But you always could find interior angles by simply setting up an equation with the exterior angle because they're supplementary. All right, on to our last one here. So the last one just says, find the measure of an exterior angle of a regular hexagon. So I'm going to write down regular hexagon. So a regular hexagon, what that means is, well, we have, and we're looking for the exterior angle, so we're going to extend this a little bit. We have a hexagon where every side is congruent and every angle is congruent. So all these sides are congruent, the segments, and then all these angles are congruent. Now, another way to think about this, if every interior angle is congruent, all 6 of these angles on the inside, if they're all congruent, well, if this angle right here that I'm focusing on is supplementary to this angle down here, I'll mark it off with 2 arcs here. If these 2 angles are supplementary, and these 2 angles are supplementary, since the interior angles are the same, the exteriors are going to have to be the same. And this is true because it's a regular hexagon. So all of your interior angles, I'll just do it 1 and 2 here. Your interior angles all have the measure of the same as angle 1. All of your exteriors are going to have the same measure as angle 2 because they all have to be supplementary. And since every interior has the same measure as angle 1, every exterior would have to have the same measure as angle 2. So we know all these are going to have the same measurement. If we, instead of calling them 1 and 2, we can call them x and y. So all the interior angles have a measure of x, all the exteriors have a angle measurement of y. So if we think about this, there are 6 exterior angles of y. All the exterior angles, well, they should add up to be 360. That's true in every polygon. It doesn't have to be regular, it could be any polygon, but it should add up to 360. We have 6 y's that we're adding together, so 6 y's equal 360, divide by your 6, and that would be 60 degrees. So y is equal to 60, or this angle, exterior angle measurement, is going to be 60 degrees in a regular hexagon. And if you wanted to find the interior measurement of one of these angles on the inside, you would just do 180 equals 60 plus now our x. So x would equal 120, which means the interior angles are 120 degrees. And I think the other day we did a measurement trying to find the measure of an interior angle of a regular hexagon, and we got 120. So all these angles on the inside would be 120, and all the exterior angles would be 60 degrees. All right, that's all we have for today. See if you can apply these to some problems on your own. Have a good day.